Okay, don't rock us again, the exploits return. Hi everyone, and thank you for joining me today, and thanks Grey Hat for inviting me to speak here. So this talk will present my follow-up research on RUCKUS Wireless. RUCKUS is a wireless solution company owned by COMMSCOPE. I first noticed them when they partnered with Black Hat to provide the conference Wi-Fi solution. And in the last year, I've been doing vulnerability research on RUCKUS devices. So far, I managed to find several critical vulnerabilities. Some of them I will demonstrate today. My previous research was introduced in the recent CCC convention. Yeah, that was way before the COVID-19. Okay, but before I begin, I would like to do a quick who am I. So my name is Zror. I'm a research team leader at Aleph Research by HCL AppScan, and I've been doing reversing for some time. I like to focus on offensive embedded devices. Okay, so I would like to begin with a short recap. In my previous research, I demonstrated 3 ways to execute code on RUCKUS devices. All of the vulnerabilities were on the device web interface. So my first RCE was credential leakage with SSH jailbreak. My second RCE was unauthenticated stack buffer overflow. And the third one was command injection that was reachable without authentication by writing a web page. So for this talk, I will be using RUCKUS R510 Unleashed. The Unleashed version are access points that don't rely on Wi-Fi controllers. Moreover, all access points on the list we can see here share the same vulnerable codebase. I also noticed that some vulnerabilities works on Zone Director, which is their Wi-Fi controllers. Alright, so what's new? Well, this research began right after I downloaded RUCKUS Fix for my previous research. I noticed that they did not fix one of my vulnerabilities correctly, and I then decided to try to re-enable it. Besides of that, my first research was entirely based on device emulation. Now that I own an actual device, I can try to see if I missed something or something went wrong with the emulation. Yeah, but before I begin, I would like to introduce a new Ghidra script that really helped me with this research. Well, in my previous research, I wrote a Ghidra script that fetches function names from log strings that RUCKUS left in their binaries. As you can see here, these are the logs. This script helped me rename functions by parsing these logs line that contains the names of the function itself. For more information about this specific script and its generic version, feel free to check our GitHub account. And although this script was super useful, not all binaries RUCKUS wrote by themselves. It's a common thing for embedded devices vendor to use open source project in their devices. RUCKUS decided to base their web server on a popular project called EmbedThis. So they had to extend its functionality by adding code to it. And since EmbedThis sources are public, I didn't really need to reverse the entire web server binary. It was easier for me just to review the source code. But what about the parts that RUCKUS added? I would like to be able to mark these specific parts in Ghidra, so I'll know I have to reverse them. For this, I wrote an additional Ghidra script. My new script tries to extract as many function names as it can from EmbedThis source code. Luckily, I discovered a debugging function that contained the exact C file name and line number in the embed these sources. Here we can see that for this unnamed function from the web server binary, we get that this function appears in server.c file around the line number 138. So if we'll go to this specific line in the embed these sources, we'll be able to extract many function names from it. This is the function in Ghidra after the conversion. These are the function name that I was able to extract from the sources to Ghidra. And let's take this function call graph for another example. The function name is MACreateWebServer. It's being called from main, and as we can see, it calls other functions as well. On the right hand side, we see all of the function name I was able to fetch by using the script I just introduced. On the bottom left side, we see the function name I was able to fetch by using the script from my previous research. And you can also see there are still unnamed functions left, but still the majority of functions are now named. So this is a great example how these two scripts really helped me and saved me a lot of time on manual reversing. And yeah, I'm now in the progress of writing a more generic version of this script. Once it's done, I'll share it in our Aleph Research GitHub account. And anyway, you can still check our account and see our other tools and previous scripts. Okay, so I think now we're ready for some exploits. This is my first RCE. In this attack, I found another Stack Overflow that was reachable without authentication on the web request, on the web server. And yeah, I'm going to try and do a live-ish demo, which is the same as live demo, but not. Okay, so here's my terminal. And let's see, there's this Stacko Webs, and let me just show you what it contains. So, oh, whoops, no, forget about it. I got another way. So I'm going to use a script that our team member Itai Greenhat wrote, and actually it makes my life way more easier. I'm just going to use the script, give it the device IP and port, and here we go. So as you can see here, it checks that the web server is up. Now it crashes the server, and it just waits for the server to restart. We're doing it because we want to make sure that the memory of the server is as clean as possible, and we found out that by crashing the server we get more deterministic results. So we just wait for the server to come back up any minute now. As I said, you still get the experience of live demo, although it's not live, it's live-ish. Any minute now. Well, if worst comes to worst, I'll just cut it away. Oh yeah, okay, awesome. So here we got that we managed to leak an address from the web server. This is actually how we bypass the ASLR. And as you can see, the exploit works, and now we are on the server, and our user is root, which is of course part of the where we are. Yeah, so this is the part of the root group, and this is it. We just exit. Awesome. Okay, so let's understand what we just saw here. So before I get into the vulnerability, I would like to do another quick recap on my previous talk just to create the right context. So there are three important binaries in the web server interface. /bin/webs is the actual embed this web server. It handles HTTP requests and executes handlers according to its configuration. It then sends command through a Unix domain socket to emfd. /bin/emfd is an executable that contains the web server logic. It maps function from the web pages to their own function. It then implements web interface commands such as backup, network configuration, retrieve system information, and much more. And the last one is libemfso. This library is used by emfd for web authentication, input validation, and some code execution. Okay. And so please note that the Stack Overflow I just demonstrated was found on this /bin/webs binary. And now let's look at another example in a diagram. So webs listen to HTTP/HTTPS. If it receives a JSA page request, it uses EGS handler to pass a function name to emfd. emfd then checks if the function name is mapped, and if so, it calls the right function pointer. Eventually, emfd runs some kind of shell command, for example, ifconfig, iptables, route, and etc. And since the web server contains both embed this code and RUCKUS code, I decided to mark RUCKUS function with an RKS prefix. RUCKUS has added a function that registers new ESP functionality. ESP is a handler that runs if the web server receives a JSP request. And here we can see that 12 functions are being registered. Each function registrations needs a function name string and a function pointer. And now I would like to explain how we can reach those functions with an HTTP request. Okay, so for example, when sending an HTTP request to /admin/webpage/Wi-Fi network wlan sysconfirm.jsp, the web server invokes an EGS handler, and on this page we can see that EGS script have this special tag, and EGS function are being called from it. And so webs maps every string it received to a function pointer and then runs it. And here we can see that a function called escapedjstr is being called. And another function named s is also being called. And yeah, they actually named the function s. Okay. So when I reviewed these functions, I noticed that s, str, escape.js, and getCookieValue are all using unsafe string copy. That means if I can find a web page that passes the user input to one of these functions, I will be able to smash the web server stack. So for that, to search for an input that leads to one of these functions, I decided to use the grep command. I search if there are any calls to one of these functions with a non-static value. It also should not be a session-related value because I might not be able to control them. So this is the regex that makes sure s doesn't get any value inside or inside a double quote or single quote. I managed to find two pages this way. One was an error page which did not receive any user input, and the other was this wlan sysconfirm.jsp. Okay, so let's have a look at this page. So we saw that S function receives a non-static value called content, and thankfully the content variable is set directly by an HTTP body parameter called content key. So I just needed to send the right request to wlan sysconfirm.jsp, and I managed to smash the stack. Yay. Okay, so as for exploitation, well, R510 uses both NX and ASLR. And first I decided to go with a brute force approach to overcome the ASLR mechanism. That was my old exploit. However, I realized that I can do better. And with the help of our team member Itai Greenhat, we were able to leak a memory address that helped us overcome the ASLR in a more elegant way. So here's the vulnerable function. Our overflow happens on line 21. And please note we control the PC only when we reach the function epilogue. It means that before we crush, we call the function EGS write string. And luckily, this function sends us the overflowed buffer as an HTTP response. Yeah, that's the function. So when debugging this function, we also notice that right after our buffer, there is a pointer that points to a value on the stack. This is a pointer. And if we can get its value, then we'll be able to calculate other information needed to bypass the ASLR. So thankfully, our buffer, if we overflow our buffer carefully, we can overwrite its null terminate char, which is here. And yeah, we can just replace it with overflowed stuff. So now in our HTTP response, we get all the AAA we see here and the pointer value. Now that we can calculate libc's system address, we simply used a single gadget and execute our command. Itai also created the Python script I used for the demo, yeah, which makes life really easier for everyone. Okay, yeah, and this is the gadget we used. Okay, so that was the first attack scenario. And before I continue to the second one, I would like to go over some other vulnerabilities I found. So I managed to find cross-site scripting, denial of service, and information leakage that might lead to another jailbreak. All of them were found either in the web server or in EMFD. I discovered this XSS on my first research, and well, it's pretty straightforward. So for every Ajax post request to /admin/ WLA cmdstat.jsp, it has to contain an adapter attribute. This attribute is simply reflected without any validation back at the response. So all I had to do is to send this specific payload, and I managed to run JavaScript on my browser. And now for the denial of service. So, well, this one I simply came across while I was researching the device. I must say I did not invest too much time in understanding this bug, but it's either related to embed this or to the code RUCKUS added. But simply when you add when you send this post request to the server, it just crashes. And the last one is the information leakage. So, well, RUCKUS consider the device serial number as a sensitive information, And in my previous research, I came across some functions in their CLI that rely on this device serial number, specifically to get a busybox shell to jailbreak. And in this research, I noticed that upnp.jsp page, which is reachable without authentication, contain very useful information. And yeah, some of this information can be used for device fingerprinting. But the best part is that I can get the serial number as well and potentially use it for jailbreak. Okay, awesome. So this is it. This is the time for my second RCE. And in this attack, I found a way to reuse the previous command injection vulnerability from my research. And I found a new way to bypass authentication by overwriting admin credentials. Okay, so let's first understand how command injection used to work in my previous research. So EMFD executes code in a messy way. EMFD sometimes uses libc, other time calls the shell script syswrapper.sh, and sometimes just run commands by itself using libc. These are all the different functions that EMFD uses to execute shell commands. And as we can see, there are many libc system function calls. So I had to find a page that uses this system function without input validation. I found 4 functions that call system and were vulnerable to command injection. Today I will be using cmd import avp port for my demonstration. Okay, so to reach the vulnerable function, I had to send an Ajax request to /admin/_cmdstat.jsp. This request uses an EMFD command called import avp port. When EMFD receives this request, it uses a function called cmd import avp port. And this function uses libc system function in an unsafe way. Let's have a look on the function decompiled code. So on my previous command injection, all I had to do is to pass a command injection in the payload attribute, and as you can see, it just executed without any input validation. The only problem was that I had to be authenticated to reach this function. As you can see here, I must have a valid cookie and a CSRF token, etc. Okay, so now that we understand the previous command injection, let's have a look on RUCKUS fix, under the fix that RUCKUS decided to use. They decided to use this function called isValidateInputString that's supposed to validate there are no injection characters in the upload file attribute. And well, they didn't just use it for upload file attribute. It's widely used in their EMFD binary. So let's have a look at this validation function. Here are all the forbidden characters for a given input. And when I first look at it, it seems like a pretty solid validation. However, some very important characters were missing from that list. So something I like to do when I'm reviewing a validators is to create a set of all the printable non-alphanumeric characters that can pass this validator. And after some trial and error, I realized the Shabang sign, which is a pound followed by exclamation mark, is a valid input. So, and I can also use a slash. So yeah, I could use a Shabang /bin/sh, which is good. but not good enough. I couldn't just append this payload to my command run by system. Okay, and this happens because Shabang has to be in a line of its own. But luckily, I could also use a new line character. Yeah, that's right, new line character as a parameter input was not being validated, not in the web server, not in EMFD, nowhere. And the result of Shabang plus new line is a match made in exploit heaven. Okay, so that was great news. I can now replace my injection with a Shabang, but there's only one last thing to solve. Space character was also not a valid input, so I just decided to replace it with tabs. So let's have a look on the new payload. You can see that semicolon was replaced by Shabang plus new line, and the spaces were replaced by tabs. And that's it. This is how I was able to re-enable my command injection vulnerability. Last thing I had to do to complete this exploit was to bypass authentication, because RUCKUS already fixed all my previous authentication bypass. Okay, so now I would like to explain how the admin credentials are stored in the device. So system.xml is the device general configuration file. It contains the admin credential as well as other important configurations. Here we see the admin XML element, and you see that its password is being stored in X password attribute. While working on this exploit, I noticed that RUCKUS has decided to use the most secure mechanism for storing sensitive passwords. You might look at my X password attribute and think, hey, your password is 2345BCD, right? But yeah, it's not the case. My actual password is 1234ABCD. And yeah, RUCKUS are obfuscating the password by adding 1 to each character. I don't get it. I got no idea why they decided to do that, and frankly, I don't really care. Yeah, but let's have a look on the /admin/WLA-conf.jsp page. We can see that this page calls for two functions in EMFD, without logging access check and AjaxConf. Please note that we must first pass the without logging access check function to get to the vulnerable AjaxConf function. So without logging access check expects for Ajax Request XML that contains either setConf or do CMD action. The do CMD action in this case was very limited in its functionality, so I just decided to go with the setConf action. setConf action uses an EMFD function called check research credentials conf para. This function expects an admin XML element with the following attributes. And this function only validates there are 8 attributes, and only check the attribute names, not their actual values. So it also doesn't check for request permission whatsoever. So here we can see a valid Ajax request with an admin element. This request has all the right attribute names, and it can reach the vulnerable AjaxConf function. AjaxConf is a very big function that does all sorts of stuff. One of them is using something called adapter setConf to update different configuration files. In particular, it can update the main system.xml configuration. And as we saw, login without access check forces me to use a specific XML element. But thankfully, this is the admin credential XML element. So now let's understand how adapter setConf works. So this is the adapter setConf function. It received the request component attribute and the Ajax request itself. I also realized that if the component equals to system, then I can only update a specific element, a specific XML element, which was not the admin element that I was hoping to change. So I can just override the admin credentials, not like that. However, if the component attribute is not equal to system, then it uses a function called repoGetCurChild. This function gets a component name and looks for an XML configuration file with that name. Also, that means I can access any XML file in the rspider directory. Well, all of them except for the XML, the system.xml, because adapter setConf makes sure it's excluded. But the credentials I want to override is in the system XML. Yeah, sucks, right? Well, this is where slash came to our rescue. I noticed that if I add a slash at the beginning of the component attribute, it's no longer a system component. It's now a slash system component. This way I was able to pass the system attribute check, and now repoGetCurChild function will look for the file /system.xml, which is totally fine since in POSIX we can add as many slashes as we want and we still get the file. Yeah. Okay, this is it. Adapter setConf has replaced the admin element in system.xml, which means I was able to overwrite admin credentials. Now I just need to chain these two vulnerabilities together. First the overwrite, then command injection to pulp a busybox shell. And since I try to be a polite person, after getting a shell, I can obtain the original credentials by grepping /var/run/rpm key, and actually this is the same file that I leaked in my previous research, and thankfully RUCKUS insists on saving passwords as plain text in their devices. So all I had to do is to repeat the attack with the original credentials, and that's it. This is how I can avoid leaving footprints on the device. And this is the time for my final demo, live-ish demo. Let's see. Okay, so I'll just start all over. Awesome. So first I would like to show you the override.xml. So as you can see here, this is the credentials override. Let me just change the password to let's say gray hat 2020, because why not? Okay, and let's go ahead and send this this payload. Okay, awesome. Credentials has been overwritten. And now I would like to use curl to just log into the device itself. So let me just do a quick login, gray hat 2020. Okay, I got myself the CSRF and cookies. And now let me show you the new, my new command injection. So this is the new command injection, As you can see, I'm using telnet D, and I'm gonna open a telnet listening to port 7331. Okay, and so let's first log in. Wait, I did log in, sorry. Let me just find okay, this is it. So this request sends the payload. The only thing I need to do is to update my credentials, which is this cookie. Here it is, and this CSRF token, which is here. Okay. Awesome. And now the moment of truth. Let me just log in to the router on port 7331. Awesome. And as you can see, again, I'm the root, and this is it. This is the router. Awesome. Okay. So in conclusion, I demonstrated today 2 pre-auth RCEs. The first one was pre-auth stack buffer overflow with ASLR bypass. And the second was command injection with credentials overwrite. I also introduced my improved Ghidra script that really helped me with this specific research. RUCKUS was informed about these vulnerabilities. I requested 6 CVEs and they confirmed them. In a total, these 2 research concluded in 17 CVEs and 5 different RCEs. And as I said in my previous talk, if any RUCKUS user listen to this talk, please stop what you're doing and check that you're running their latest firmware. And yeah, so this is it. These 2 research were tons of fun. I'm really glad that I helped RUCKUS making their equipment better. I already posted my blog post about this research, so feel free to check alephsecurity.com. You can also find there my previous talk and other amazing research done by our group, so make sure to check it out. And this is it. Thank you very much for your attention. Stay safe and healthy. Thank you.